So I had a request to do on section 2.1, number 42, because we found a glitch in the technique that the book talks about. So there's a way to deal with this. So let me show you why there's a glitch, first of all. So the high number was 26 in the data, the low number was 7, and they said use 6 classes, which is 19 over 6, which is 3.1-ish. And so I rounded up to 4, and my class width was 4. And so what I did initially was, by using the 4, 7 plus 4 gave me 11, 11 plus 4 is 15, then 19, then 23, then 27. Well, the highest data point's 26, so we have to make an adjustment. We need to change our class width. We don't reduce our number of classes. We don't add our number of classes. We've got to use 6 classes. So what we do is we change our width. We make our width, or by suggestion, we'll try 3.5. Now, because we're working in the decimal places now, we're going to have to think about how we work on the ones place. So, again, we start at the 7, but we add 3.5 to get 10.5. Then we add 3.5 to get 14. Then we add 3.5 to get 17.5. Then we add 3.5 to get 21. And then we add 3.5 to get to 24.5. And because we're working in the decimals now, we have to think about going one lower than 10.5. So now it's 10.4. And from 14, it's 13.9. And 17.5, it's 17.4. And then instead of 21, it's 20.9. And instead of 24.5, it's 24.4. And then again, we have to add on our 3.5 to move to that next one, because we don't have a upper limit. And you'll notice I screwed up. I had 20.5 there, or 20, and then, so I misadded for a second, and it screwed up what happened. So now I went through and I got the numbers. I got 2 in this category, 8 here, 9 here, 5 here, 2 here, and 2 here. Now, you generally work off of either the class midpoints or the class boundaries. I ask on the tests to do class boundaries. So how would you do class boundaries in this situation? Well, let's deal with the 10.4 and the 10.5. How do we make those meet? Well, to make those meet, we'd have to go to 10.45. And so over here, the lower, the 10.5 would become 10.45. Okay? Now, the 13.9 and the 14, well, that's going to be 13.95. And here's a 13.95. So we just always make them meet at that halfway mark between them. So this is now going to be 17.45, and this will be 17.45. And this is 20.95, and this is 20.95. And 24.45 and 24.45. And forgive my handwriting, it's generally pretty bad. So 25 point, and see how we've gone up each time. So we've got to follow that pattern. So this will be 0.95. So you've moved up that half step. So it's 27.9. Now we're at 27.95. And that keeps our bars uniform in length. And that also means that I moved the 7 down a half step in the hundredths place. So now we're going to be looking at 6.95. All right. Now, a cumulative frequency never goes down. It can go flat if the number of items in that category is 0. So cumulative frequency, it's also referred to as an ogive or an ogive, depending on who says it. So we have 2 in here, so the cumulative frequency is 2. But what happens for cumulative frequency is we always add up backwards, and backwards is the poor choice of words. But so I'm going to go back up the table. So 8 plus 2 is 10. So now I'm going to go back up the table. 9 plus 8 is 17 plus 2, well, 19. Okay, and then I go here. So 5 plus 9 plus 8 plus 2, well, that's going to be 24. Back up the table, so I'm at 26. And then I'm at 28. And the number of data points here should match the number of data points in your total table. And we have 4 rows of 7, so we've got 28 total items in there. And a real quick comment about how to find the midpoints if you were asked to do midpoints. Take your 2 class boundaries, the 7 and the, the 7 and the 10.4. So the 7 and the 10.4 right there. You add them, you'll get 17.4. And to get the midpoint, you divide by 2. Because there are a couple things in the My Math Lab that ask you to do that. So that's how you get the midpoint. That's just an aside. All right, so here we make sure that our x-axis, again, always title, always title, always title. Give a title to the overall graph, label your y-axis, label your x-axis. Okay, so here would be frequency. You can abbreviate it with frequency, and then fat intake down here. Fat intake, and then give it the title, saturated fat intakes. Okay. Make your axis follow the class boundaries as best as you can. So we're gonna go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 3, 4, 5. 1, 2, 3, 4, 5. So 5, 10, 15, 20, 25, 30. Okay, so now we're at 6.95. So we're almost to 7, and I put a line there, and I'll label it 6.95. To 10.45. So a line here. Here's my 10.45. And my frequency is 2. So 1, 2. Okay. Now, on a cumulative frequency distribution, you start at the left-hand endpoint at the lowest mark, and then you travel up to 2 when you get to the end of that group. Okay, so my next one is now 13.95, which 11, 12, 13.95, which is about here. And we're going to be all the way up to 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's 10 hash marks there. I'm going to stop after this. I'm trying to make it obvious. So we have to end at the 10. So we start at the 2, because that's where the interval started at, or left off at the previous interval, and we travel up to 10. And you keep doing that all the way across. Your graph can flatten, but your graph will not go down for an O-give or O-jive or cumulative frequency distribution. Well, I hope that helps. I'll talk to you later.